Today we're going to do a deep dive into Starknet. Last week was mostly about the fundamentals of Cairo, of Starknet, some of the architecture. Today we're going to go deeper into not only the architecture, but also to focus on some elements on the network, go into more detail about transactions and things like that. Okay, so let's start talking about transactions. Let's resume where we left off last week. So last week we mentioned that it all starts with your wallet. Could be your smartphone, could be your laptop, and you will sign a transaction and you will send this transaction to Starknet, right? And in the particular Starknet nodes that actually receive this transaction is called the sequencer. And right now there's a single sequencer for a Starknet, and there has something similar to a mempool, right? That receives your transaction and does some basic transaction validation before actually move on to the execution of the transaction. And because the Starknet smart contracts are actually Cairo programs, they'll have to be executed on the Cairo virtual machine, right? So the transaction is sent from the mempool to the Cairo VM. Then once it is executed, the trace of that execution is actually sent to Sharp, to the shared prover. And it's called shared prover because it's being used not only by Starknet, but also by all the StarkX apps, DYDX, Rhinofy, Sorare. So it's been sent to the prover module within Sharp to create the validity proof that attests to the integrity of that computation, the transaction execution. It's sent obviously to Ethereum, to a Solidity smart contract called the verifier. And if the verifier says, yes, this proof is correct, you will know that the result of that execution is a trustless way to execute code by a third party. In this case, third party is a Starknet. Okay, so this is what we saw at a high level last week. So now we're going to go deeper into this architecture. So let's talk about the transaction lifecycle. So again, you send a transaction. Obviously, you have to sign the transaction. That's why you have a signer on your wallet. It will get to the mempool. And the mempool will do something very similar. For example, it's going to check that the transaction has the correct structure, right? It has the right fields, that is well formed. Not much on that. When the transaction acknowledges that it got your transaction is now in the received state. And that is a state that you can actually see on a block explorer like Voyager or StarkScan. Obviously, if something happened, like, for example, the connection got broken between the smartphone and then your transaction is going to be ignored. Ignore is not really a canonical state. It's not something that you will see in a block explorer. It's just obviously the Starknet wouldn't know about your transaction. It would also happen that the transaction can actually go through, received by the mempool, but maybe it's malformed. Maybe you're using an incorrect client or SDK. So in that case, the sequencer also ignores the transaction because if it doesn't have the right structure, it cannot extract the data from it. But if it's well-formed and received by the sequencer, by the mempool, then that's when the signature validation actually happened, right? Every transaction has to be signed. So then that's the next step, verify the signature. If the signature is incorrect, like it doesn't correspond with the public key or the private key, then the transaction will be rejected, right? And that will be the end of it, actually. Now, if the transaction is valid, the signature is valid, then it will continue. Now it actually goes to the execution in the Cairo VM. So at this point, if the sequencer is able to successfully execute the transaction with the Cairo VM, it will get the status accepted on L2. And that's what we call as the finality on layer 2, right? Because at that point, Starknet will know what's going to be the new state of the network as a result of executing your transaction. But if something happened, for example, you ran out of gas during the execution, you didn't have enough tokens or Stark tokens to pay for it, or it could be that during the execution, it hit an assert false, and when that happens, the transaction stops the execution and it is reverted. You will get charged to the point that execution actually happened, but it will be the end of it, right? But now, even if it goes through or if it fails, a trace is generated and sent to the prover as before, right? The prover creates a validity proof. And if that validity proof actually is accepted by the verifier on Ethereum, then the status of the transaction will be accepted on layer 1. And that will be like the finality on layer 1. So just to summarize quickly, so your transactions go first received. If it's acknowledged, received by the mempool, it has the correct structure. If it fails the execution in the Cairo VM, it will be rejected and execution just stops. If the trace sent to the prover, if the execution is correct and it actually completes, it's mentioned to be accepted on L2, finality on layer 2. If not, it's going to be reverted the transaction. And then when the validity proof gets to the verifier, it's going to be accepted on layer 1. and that completes the cycle. Your transaction, when it gets compiled, your smart contract, it gets compiled by the sequencer, right? In the sequencer, make sure that the compiled output is safe Cairo assembly one as well. That's why we need the compiler to be able to compile your program and not you directly, because I give you that guarantee that it can handle those fail states. Elias is asking, could you explain the prover one more time? So this part right here. So basically what happens is that there's a module. Think about it like a different machine controlled, part of a Starknet, controlled by Starkware, that is called Sharp, the shared prover. And the goal of Sharp is to create cryptographic proofs or validity proof out of the execution of Cairo code. So the input will be going to be a trace of the execution, and then the output is going to be the validity proof that attests to the integrity of this computation. It's basically saying that no one tampered with the execution, because if someone did, the validity proof will be invalid, so it wouldn't be accepted by the verifier. So basically, that's what the prover does. You can go to section 1 and just recap that section that we talk about why Cairo and why Starknet. Sandra, the slides are in the chat. Just go a little bit higher. I just shared there. Hui Zhao is asking how to make sure that reverted transaction can be included in the proof. And I assume the user will be charged with the gas even the transaction reverted, correct? You don't have to do anything. It's all handled by you, by Starknet for you. And yes, all the execution is going to get charged because you will be consuming resources from the sequencer to the point where the transaction actually failed and it stops. So you need to be charged for that. Otherwise, it will be a denial of service vector of attack. Question from Tim. When reverted, then a trace is not sent. The internals, I don't know exactly how it works, but it does get included into the block, which is the important thing, right? Okay, let's continue. So let's see the transaction types. We have the declare transaction, and last week we discussed the differences between declaring a code and actually deploying a new smart contract. So the declare transaction is used to register new code on Starknet, right? So every time you have a new code, you have to first declare it. And the idea behind declare it, different from deploy, is that, for example, you can have multiple instances of an ERC20 smart contract, all using the same logic, right? The same base from OpenZeppelin, but you only have to declare the contract once. And then you create instances of it that is basically only the memory layout of your smart contract. You don't have to redeploy the same bytecode over and over. So it's more efficient that way. So to declare, there's a particular transaction for that purpose. Then there's another transaction for invoking smart contracts. It's called the invoke transaction. And that's the one that executes write functions. Last week, we talked about there's basically two types of method that a smart contract can have. One could be a read-only, and then another one that is write, that actually modifies the state of your smart contract or another smart contract that is calling. Then the third and final type of transaction is the deploy account transaction. And this transaction only it's used to deploy account contract. If you recall the discussion about smart wallets, every wallet on a Starknet is actually a combination of a signer and a smart contract, a particular smart contract with a particular interface that is normally known as the account contract. So to deploy that account contract, there is actually a deploy account transaction, right? It's a slightly different workflow than deploying a regular smart contract. And we're going to see an example of this later, of how do you actually deploy an account contract, which is different from a regular smart contract. Now, all the transactions that modify the global state, for example, declaring, invoking, or deploying an account, it actually is going to charge you for gas fees, right? You will have to pay for it. If you're invoking a function that is a read-only that doesn't modify the state, then it is for free, right? You don't have to pay anything because you're not modifying the global state in any capacity. So people might be wondering, how come there's no deploy transaction? And we discussed this last time, right? There's a thing called the universal deployer that actually takes care of that. So the universal deployer is a smart contract that actually handles the deployment for you. And to call that particular smart contract, the universal deployer, you have to use the invoke transaction. So in reality, you use the same invoke transaction either to interact with a smart contract or to deploy a smart contract. It's just when you deploy it, you have to invoke a very particular smart contract called the universal deployer. Hitesh is asking, where can we find recording of this? You can go to the Starknet Foundation YouTube channel. We have a playlist for Basecamp 9, so make sure to check out the session 1. Okay, so 3 types of transactions. declare, invoke, and deploy account. Okay, now the question is, how do you deploy an account contract, right? That's connected to your wallet, which I mentioned is a little different than a regular smart contract. Here's the thing, right? So to create a smart wallet, I mentioned that you have a signer, say your phone, but you also have to deploy the account contract to Starknet mainnet. But to deploy an account contract, you have to pay gas fees, right? Because you will be modifying the global state with new code. But to pay for gas fees, you need a smart wallet. And that is like a chicken and egg situation, right? Like a circular reference, like to deploy a smart wallet, you need to have a smart wallet, which is obviously not ideal, right? You should be able to deploy an account contract without having a smart wallet if it's your first. So how do we get out of this circular reference? So the solution is actually counterfactual deployment. That's how the process is called. And the way that it works is that, let's say you create your first smart wallet. The signer is obviously your device, but then the client is actually able to calculate the address of what's going to be your account contract even before it's deployed, right? Because it will know which parameters you're going to pass, and based on those parameters, it can derive the address. So the address is known to you even though nothing is deployed there yet. Then you can actually send funds to that address. That at that point there's nothing there. The address is not claimed by anyone, but you know it's going to be yours once you deploy it. So you will send their Stark tokens or ETH to that address, right? So now you can actually deploy your account contract using the deploy account transaction. And what's going to happen is that the sequencer is going to deduct the cost of the gas fees of the deployment from this address that has been pre-funded by you with some tokens. So this is how you manage to deploy the account contract, right, as a type of smart contract without having a smart wallet to pay for gas fees directly. You pre-fund the address even though at that point it's empty, nothing's there. And then the sequencer knows that it can actually withdraw the amount for gas fees from there. PCWU asks, can we follow the same way with a customized account contract, the way to pay gas fees? Customized account contract. I mean, I don't know what you mean. I mean, you can technically deploy an account contract just using another smart wallet to pay for gas fees, right? You can treat it as a regular smart contract. The only issue is that normally for a wallet, you want that wallet to have a pristine start that is not connected to any other wallet, because otherwise you leave a trace. Oh, this wallet deployed this wallet, this wallet deployed this wallet, which is not ideal. So yes, you can use it in like a regular smart contract. You can just pay gas fees for the smart wallet, but ideally you want to have this counterfactual deployment, so there's no trace of who deployed it. It just came to life one day. Nico Sanchez asking, is this the paradigm that all blockchains follow, or is it Starknet specific? I believe that also on Ethereum, we have something similar now that ERC 4337 is also active. So they also have a kind of abstraction. I believe they have something similar. I don't know if it's exactly the same, but the name is the same. So you can find it also videos on how it works in Ethereum. But the principle, I think, is similar. All these things that you see in Starknet, especially with an account contract, is actually inspired by all the research done by the Ethereum Foundation or the Ethereum ecosystem. It's just that we actually deploy these features way before they became active on Ethereum. So actually, before all the complex research got finalized, so we actually had to create maybe our own flavor of that research that came from Ethereum. Elias is asking, who signed the transaction to deploy account contract if you don't yet have the private keys? Oh yeah, no, at that point, the signer, you will have the signer, right? Because the signer is just your device. So we assume that obviously you have a device, either your smartphone or your laptop, to sign transactions. What you don't have is the other part, is the account contract. Let me know if that's not clear. I can just go back to it. Seth is asking, since the smart wallet will still be signed by EOA internally, signed by EOA, we don't have EOAs on Starknet. That is a concept that doesn't exist. If I have my Star token in my EOA, maybe try to rephrase the question, because when you mention EOAs, that doesn't apply to Starknet. It only applies to, well, basically any other EVM chain, but in Starknet, everything is an account contract, or everything is a small wallet. So Olamide is asking, can you explain the counterfactual deployment process again? Yeah, sure. So imagine that you install first, let's say you install Bravos, the app on your phone, right? You install Bravos, and then you say, okay, Bravos, give me a new wallet, right? And Bravos will show you a new wallet with an address and everything. But the thing is, the only thing that Bravos is doing at that point, or Argent will do the same, it's only actually using your secure enclave to create a private key for that wallet and define the signer of your wallet. But it's actually, it doesn't exist the smart contract associated with that. It doesn't yet deploy. But the wallet, the address, is actually can be known beforehand because it only depends on the class hash and the constructor argument. So those things can be defined beforehand. So because they know the address, now you can send funds to that address, even nothing exists to that address, but you know that address will be yours when you deploy the account contract. And then when you send the deploy account transaction that your Bravos mobile wallet or agent will actually allow you to do, what it does is send the deploy transaction, and the sequencer is going to actually take some of the fees or some of the tokens that you send to this address, and it's going to use that to pay itself for the deployment of your smart contract or your account contract to that particular address. So that's how you have a pristine start of your smart wallet. It all happens under the hood when you use Argent on Bravos. But if you dig deeper, if you create just a smart wallet and do nothing, and you try to go to a block explorer to see what's behind the address, you'll see that it's empty. It's only after you do the first transaction that they actually do this loop. So they went to you try to do something, and they use the multi-call feature to actually first deploy the account contract and then do the activity that you want to perform. But there's an option to actually manually deploy the account contract, but you have to search through the settings to find it. Maybe you can find it. I'll show you here quickly. It will make more sense. I don't remember which password I gave to this. Give me a second. Okay, what I can do is just uninstall this, install it, because I don't have anything here. Let me do it with Bravos now. So I'm just gonna remove it because I forgot which password I use. Let me reinstall it. Add it here. Now it's available. I create a new wallet. I did this last time. I just forgot the password. What password I'm gonna use? Just gonna use Basecamp so I don't forget it. Basecamp. All right. Yeah, save it, whatever. Done. Okay, I understand. Let me go to testnet just because I don't want to use real money right now. Let's go to Sepolia. Let's see. Let's proceed. Okay, I'm in Sepolia. All right. So technically, I have an account. I have an address, even though nothing's been deployed. There's no money in my account. So look at the browser is able to pre-calculate the address. If I try to take this and go to, let's say, Starknet, or let me open also Voyager just here to compare. And if I go to Sepolia and try to search for the address, there's nothing, right? It's unable to find the account contract because it has not been deployed up until that point. Same if I try to do here, go to Sepolia, try to search for it, searching, and nothing, okay? What I can do now, I can go, first of all, I will need some tokens, so I can use the faucet. I can use the address, even though nothing's been deployed there, right? It's just, I know when I deploy, it will be deployed to the address, but it doesn't exist yet. I can use it for the faucet and say, hey, send me this, let's say some Stark tokens to this address, and I solve the CAPTCHA. Hopefully that's enough. Wait, okay. I have 20 Stark tokens now. So if I want to manually trigger the deployment of the account contract, I can go, if I remember where, I think it's from here, set up your account on chain. Yes, I think that's the one that I can manually deploy the account contract. So this is the deploy account transaction that is being sent under the hood. And in theory now, if I go, it could take a while to update the explorers. It's not immediate. They have the indexers getting all the data. But now I should be able to actually see the account contract being deployed at some point. Let me see if it's completed the transaction. Account deployed. If I see the details, you can see the status, right? Received. It goes to the mempool, the sequencer, and it got accepted on L2. So it was successfully deployed, basically. So I should be able to try again the address. Let's see, can I see it? Is that the address? That's the thing. It takes a while for these block explorers to refresh with the new data. Yeah, but it's been deployed. You can see here all the information on the transaction being completed. If I see the event log, is it showing somewhere? No, it's not showing here. Look at the transaction type is deploy account, the one that I mentioned. Maybe I can go back this little later once it's been indexed correctly and just show you because it might take a few minutes. I want to get stuck here, but remind me to go back and to show you now the account contract that's been deployed on testnet. Click in sender account here, sender address. Is this my same address? Not deployed. That is strange. It will take a while, but in theory, it's now available to be used. Time and nothing yet. Let me see the wallet. What does it say? Yeah, it says that been deployed, so it just matters just waiting a little longer until it's picked up. All right. Olamide is asking, you explain the counterfactual deployment? Yeah, I explained that one. I'm asking, can someone share the link to the replay of the session of the last week? I think it was shared. Someone shared with you. Yeah, answer, Robert. Thank you. Yeah, and starting YouTube. Leon asking, who pays for the ETH fee to include the proof on L1? Oh, interesting, right? Because you mentioned about this, right? Because this is a transaction to the Ethereum, and because you will have to pay Ethereum with ETH to pay for gas fees for this verification. So who's paying for it? And the thing is that Starknet collects fees from you, and under the hood is going to use those fees or part of it to actually pay for the fees to submit this transaction to layer one. And there's an interesting topic here because there could be a spike in price from the moment that you send transaction to the moment the associated validity proof is sent to layer one. And there's some economics in place to try to smooth out that difference. But yeah, but it's one of the challenges for layer two. So basically, the Sharp has an EOA for Ethereum to pay for transactions fees in Ethereum. Tim is asking, I think it was been answered. Seth asking, okay, in each smart wallet, does it still require a set of public-private key pair from my wallet to sign transactions for it to process? Yes, that still applies. You need to have a private key, which is controlled by the secure enclave of your smart contract of your smartphone, if you enable the hardware signer feature, right? Because otherwise, it's just exists. The private key will exist just in the memory of the app. And if so, I was wondering if there will be a scenario where I have a Stark token on the address of a public-private key pair, which then the wallet can use during the deployment of my smart wallet. Yes, that is actually exactly what I did. I just sent from the faucet, I just sent Stark tokens to that address, and then use those tokens to deploy my account contract. Bernardo is asking, so what are we doing is constructing a transaction that will deploy the contract, but we will hold off on broadcasting it to the network until a later time, right? Yes, you can delay as much as you want the actual deployment of the account contract. It's up to you. Actually, just to make it easier, the Bravos and Argent, they actually wait until you do the first transaction, let's say interacting with a DeFi protocol or sending ETH to someone else, to actually first deploy your account contract and then execute your operation. So you don't have to manually deploy the account contract, right? So it's easier for the regular user, but you as a developer can do it manually. Nico's asking, so deployment happens when you put it in funds? No, deployment happens when you send the deploy account transaction. Alpha was already answered. Seth again, does this mean that even when we deploy contracts, we will also be deploying via a smart wallet? When we deploy contracts, if you talk about regular smart contracts, not account contracts, then you deploy through the universal deployer. And your smart wallet will be the one paying the fees for that invoke transaction. So it's a different type of operations. It's the invoke transaction using the universal deployer. You can find the universal deployer. Try one more time, just out of curiosity. Oh, look at that. It's now deployed. So you can see, any account contract has this specific methods. It's valid signature, valid deploy, valid declare, blah, blah, blah. It has more things depending on the implementation. But this is the account contract, the smart contract that is connected to the signer controlled by this, let's say, browser wallet. The signer can be my laptop, or if I have the mobile phone, will be my phone designer. Karna been answered. Done. Does an account have to hold some ETH in order to send a transaction because it requires to pay gas fees? Yes, you always need. You can pay right now. You can pay fees using the Stark token or ETH. Both are valid for paying gas fees. At some point, only a Stark token will be the token to pay for gas fees. But we are working on implementing, and actually it's been implemented by some protocols, the paymaster. And the idea is that you should be able to pay for gas fees in any token you have, or maybe not any, but at least a set of tokens that you have, let's say USDC, to avoid having always dual purpose tokens, like having Star and having USDC. And what happens under the hood is that the paymaster will do the transaction, the conversion to a portion of your USDC into Stark to pay for gas fees. But for now, you do need to have Stark tokens or ETH in order to pay for gas fees. Hui Xiao is asking, does the EIP 1559 is implemented mean the tip gas will be burned? Not yet. Not yet. In fact, there's no fee mechanism right now. It's something that is being worked on. So it's actually just first come, first serve, the execution of the transactions. But I think the goal is to have something very similar to EIP 1559, but that's something that you can go to the Starknet.io roadmap. I think it's shown there. If we go to the roadmap, you can see that, yeah, transaction fee market is a thing that is actually being worked on right now, and it's going to come for version 0.14. So this is the place where you can check the progress in the roadmap for Starknet. Orlando's asking, if Bravos disappear, can I access to my account? That's a great question. How could you access? Let's say if you actually bagged your seed phrase, then yeah, basically you can derive the private key. Let's see, worst case scenario, you can derive the private key from that seed phrase and use the command line to regain control of your account contract, right? It won't be easy because now you have to do things via a CLI more programmatically, but you will be able to record the assets if it comes to that situation. All right, great questions. Thank you for the questions. Let me continue here. So counterfactual deployment, good. All right, so to summarize the transaction section, we have 3 types of transactions: declare, just to declare new code, new smart contracts on the network. If it has already been declared before and you only want to create an instance, you don't have to redeclare it. If you try, you're just gonna fail the transaction saying it's been declared. Invoke is to either to execute or interact with a smart contract to call a method, or to deploy a smart contract using the universal deployer, a regular smart contract. Then you have the deploy account transaction that is specific to deploying account contracts, part of the smart wallet, and is usually used in conjunction with the counterfactual deployment process. The transaction lifecycle, you have received when the mempool becomes aware of it, saying, hey, I received the transaction. Accepted on L2 when it's actually executed in the Cairo VM, so Starknet will know the outcome of that execution. Accepted on L1 is when the associated validity proof gets accepted on layer 1 on Ethereum. And then it could be either rejected if the mempool say, hey, this is malformed. No, sorry, rejected is, when it's rejected, I forgot exactly when it happens. Rejected is when, right, if it doesn't pass signature verification, basically. That is when it gets rejected. Because reverted, if it fails during the execution, either because you ran out of funds to pay for gas fees or because you hit an assert that returned false. And remember, to deploy an account contract, you have to follow the counterfactual deployment process, right? Question from Orlando. Is equal to an EOA. AA not provide an additional way to recover it? No, I wouldn't call it an EOA. No, it's because there's always an account contract. There's always a smart contract on the blockchain that is the one that actually controls your assets. So in that case, the EOA doesn't have a counterparty on chain. It's all just the private and public key in your device. Bernardo is asking, the rejection can only happen before L2 or can it also happen after it? It can only happen on L2. What could happen? I mean, one of the worst case scenarios will be that maybe the validity proof it's just not accepted on layer 1 and for whatever reason. So that will create a reorg of blocks. And it could be a big reorg because we send validity proofs every 2 hours. And in those 2 hours, a lot of blocks have been created on layer 2. I think it has happened once or twice, not because no one cheated, just because whenever there's a big update, sometimes it takes some time. So for this thing to propagate, if I'm not mistaken. But I mean, the actual status of rejected is only happens on layer 2 execution by the sequencer in particular. Nico is asking, it's accepted in L1 when it's verified by Ethereum, right? Yes, it's only when it's verified on Ethereum. All right, great. Sorry, next topic is data availability. And that's a very interesting topic, especially with all the updates that happen. Mayowa, I know you have your hands raised, but if you have a question, please use the Q&A to ask a question. So let's talk about the liveness problem. and the reason why we have data availability. So you know that to go from, let's say, a state n on a Starknet to state n plus 1, so the next state, because at the end, blockchain is just a state machine, right? It goes from state A to state B, and the transition happens is because a bunch of transactions gets executed in the middle that changes the state of the network, right? The transactions in a block. So in the case of a Starknet, those transactions are executed with the Cairo code. So obviously, to do this transition from state n to state n plus 1, you need to know what's the current state. What is the state n? So who can tell you what is the current state in order to progress to state n plus 1? Well, you can get the current state either from the sequencer directly, or more likely from the layer 2 full nodes. And the full nodes is equivalent to, let's say, an Ethereum execution layer in a way. It's not exactly the same, but that's the closest resemblance that we have. We actually have 3 different clients. We have Juno, Papyrus, and Pathfinder. Differences stem from in which languages they were written. Some are written in Rust, some are written in Go. It depends on, they all have the Cairo VM embedded in it. So it depends on which implementation of the Cairo VM they're using. But we have 3 that you can choose which one to use. So from, there's a single sequencer in the network, but there are many full nodes, right? You can run a full node today if you want to. So that's how you get state n to then execute transaction and get to the next state. But the question is, what happens if by, crazy scenario, the sequencer stopped responding and then all the layer 2 full nodes also stop responding, which is a very extreme scenario, right? Because at least with layer 2 full nodes, you have plenty of redundancy. Well, if that happens, it means that you're not able to know what the current state is. So even if you know the transaction that should be executed next because they're part of a block, you won't be able to transition to the next state because you need to know the current state in order to transition. So in that case, Starknet will get stuck. And this is a problem of any blockchain, right? If you don't know the current state, even if you know the transaction, your blockchain is going to get stuck because it's a state machine. So you need to know the current state in order to transition to the next state. Seth is asking, do all the L2 full node has the full data of the L2 chain from the Genesis chain? I think it depends how you configure the full node, but if you want to, yes, you can have it with all the transactions from origin. Will you have all the details? Yeah, I think so. It will have all the blocks from the beginning, but it's configurable. I think it depends on the client. You can see the docs how to perform it, but in principle, yeah, the same as with an Ethereum client. If you want to, you can execute all the transactions from the very beginning of the Genesis node up until today. Okay, so where does it fit this data availability? How do we prevent from the network getting stuck by not knowing what the current state is? So once the prover finishes sending the validity proof and is verified on Ethereum, there's a next step. And that next step is actually send the state difference from state n to state n plus 1. Whatever changed between those things are sent to Ethereum as a blob. And that is one of the biggest changes that happened recently with the introduction of prototype sharding. Because before, this state diff used to be sent as cold data using multiple transactions. It was super expensive to do, which in turn made Starknet transactions also expensive because you have to spread out the cost. But with the introduction of blobs, actually, it became very cheap to send this difference of what changed in the state to be at least published on Ethereum. Question from John. What is the difference between sequencer and L2 full node? So sequencer is the only node capable of organizing or receiving new transactions and minting new blocks or creating new blocks, right? Full nodes, they have no capacity of creating new nodes. They only know what the current state of the network is. So anytime you use an app on a Starknet, say a DeFi app, and all the data that is being shown on the screen is actually coming from a full node, not from the sequencer, right? The sequencer only gives you data from what is the last block or something like that. It doesn't give you details about transaction. Those details exist only on the full nodes. It doesn't give you the details just because it doesn't want to, because we don't want to overload the sequencer. We want to actually distribute the load for full nodes that anyone can run at home if they want to. Victor is asking, what are blobs? Well, that's a question from Ethereum, but every blockchain has block space, and the block space has become expensive, and it's also it has a tendency to peak. So the idea of Ethereum is that having 2 different type of markets for, let's say, transactions. One is for the regular block space used by anyone using, let's say, Uniswap or things like that on layer one. And another one for blob, where the data is only pretty much just bytes without any particular format. So the EVM doesn't really know or has access to the blob space directly. It's only meant to be used really by rollups or people doing inscriptions. So it's only temporary. It's only being held for 1 month. And because the EVM doesn't have access to it, and because it's a different fee market, it's actually much cheaper to send a lot of data into a blob than it is to try to use a block space. That's how layer 2s became very cheap in recent times. Elias is asking, could you please explain how blobs make transactions cheaper? Yeah, because basically it's unstructured data. It's basically, hey, here's a bucket. You send whatever array of bytes you want. As the EVM, I don't care what is there. And actually, I'm gonna delete whatever you put there after a month, right? It's not gonna be there for life. So that's basically why it's so cheap. Seth is asking, in the item 5 state diff in the diagram, what data is exactly being stored in the ETH blob space that can be challenged by fraud proofs later? We don't have fraud proofs. Fraud proof is for optimistic rollups. So just keep that in mind. Basically, the state diff, which I'm going to explain in a moment, is just whatever changed from state A to state B. Let's say if from state A to state B, the only difference is that you have one more ETH. So that's the only thing that we send, like a +1 for your smart contract. Timmy Top is asking, if Ethereum doesn't have access to blobs, how does verifier on Ethereum makes use of it? So interesting question. So the validity proof, it is sent as a regular transaction to the block space, right? Because the EVM needs to be able to run the verifier to verify the proof. So this hasn't changed. It's only the state diff that is actually using blobs. Who is just is asking, there is an assumption that someone will back up the blob data and save it in permanent storage, and there is no incentive for permanent storage of blobs. So if no one backups the blob, no one can rebuild the state anymore. The NDA is meaningless here, correct? That is correct in the sense that yes, that now you cannot recreate the whole state of a Starknet only by looking at blobs, because it can actually be dismissed after a month. But at least for a period of 1 month, anyone can check that information. But you're right, it has lower liveness guarantees that we used to have before. Yes, especially if no one is trying to store all those blobs happening over time. But you will always have also the layer 2 full nodes as well. So you can reconstruct the state from the sequencer, from the L2 full nodes, and for blobs up until 1 month. But yeah, it's lower liveness guarantees than before, that's for sure. Ayush is asking, can I see the data availability slide again? This one? Here. You'll have the recording. You can go back and just take a look at it. But let me finish the discussion about data availability, because I think it's important here. So because I mentioned that you send the state diff to layer 1. But what is the state diff? So imagine that on a Starknet, Starknet eventually started with a genesis block, right? With an empty state. And then you have the genesis block, then you have block 1, block 2, blah, blah, blah. So if you execute the transaction of all these blocks, Genesis, B1, B2, you will get to a new state, right? And what you're going to do, you're going to calculate, okay, how is this new state different from the previous state? So obviously the first time is exactly the new state because it was empty. So you will send that to layer 1 as a blob. Then you will have more blocks happening over time, block 3, 4, 5, these are blocks on layer 2. And then after a while, you will say, okay, let's see how the state changed from the last one that I sent the state diff to layer 1. And I'm going to send those changes to layer 1 again. And well, this actually it's outdated, this slide, because this is what someone was mentioning. Before, when it was block space, you could reconstruct the whole layer 2 state just by rehashing or playing out this state diff one on top of each other to what was the new state or the current state of layer 2 using some kind of layer 1 indexer. With blobs, if no one is storing that data after a month has passed, this is no longer really possible. So I need to update this slide, basically. This is how it used to work when it was block space. But to understand what is actually sent, let me give an example of what is the state difference. Imagine we have 3 people, Jimmy, Rose, and Nick. Let's say that Jimmy sends 1 ETH to Rose, okay? And then Rose sends half an ETH to Nick. So what is the state at the end of this execution. Let's say these are 2 transactions. So the state diff will be that Jimmy has one less if than he had before. Rose has half an if more, and Nick has half an if more. So that data is basically the data availability that is sent, is the difference at the end of execution, a bunch of transactions of multiple blocks. Another example, again, Jimmy sent 1 if to Rose. Now Rose sent 2 if back to Jimmy, and Jimmy sent back half an if. If you do the math here, the state diff is basically at the end, what we send to layer 1 is that Jimmy has half an if and Rose has less, minus half an if. So you can see that even though we have more transactions, the amount of data that is sent is actually less, because the difference, the things that change is actually lower than before. Before we had to send more data as data availability, even though we have less transactions. Now, this extreme case will be that all the operations cancel itself out. So in that case, we don't have to send anything as a state diff, right? Because at the end, they end up with the same state. This is an important difference from optimistic rollups, because optimistic rollups, they do have to send the detail of the transactions so the fraud proof can be created. On Starknet and other CK rollups, you only send what changed after executing a bunch of transactions, which could be very little, sometimes even not at all. Some of the questions. Tell me, Top, how do you access the blobs then? Do you need an Ethereum node, or is it exposed via RPCs? Is it exposed by, well, an RPC is basically an Ethereum node that someone is managing. I would imagine that you probably can use the an Explorer, but I don't know. I'm not running currently an Ethereum node to know. An Ethereum node for sure will have access to the blobs. I don't know if with Infura or something like that, you will be able to. I don't know. Samyat is asking, what is data sample? I don't know what I use data sample. Let me know. I don't know. Maybe that's a different concept you're talking about. Can you clarify? Okay. Elias is asking, state differences sounds like Lightning Network on Bitcoin. Let's say, it's similar in the sense that, yeah, on Bitcoin you have to open and close channels, which settles. It's just in this case, the security of the network is given by the validity proof. Data availability is only for liveness. It's not for security, really. Yeah, I can see why you make that connection, but it's really not the same. Hitesh is asking, can you share the YouTube link for this and previous video? If someone can share with Hitesh on the chat, please, the recording of the playlist of the Basecamp 9, please, put it there. Okay, Robert put it on the chat. How do you reconstruct a state from blobs? I'm a bit unclear as to what happens after 1 month. After 1 month, Ethereum nodes, they just delete the blob. It's gone. Unless there's someone running an Ethereum node and has a service to actually store it for a longer time. The thing is, as layer 2 start to decentralize and have more and more full nodes, the less maybe critical having data availability in layer 1 becomes. And also, Ethereum makes the decision that they don't want to be the data availability layer 2 store for life data for all the layer 2s. It will make very unwieldy layer 1, like the rate of growth of the state. So they want to be an execution layer first and foremost. There are other protocols that want to be a DA layer first and foremost, but not Ethereum. Seth is asking, if we only record the final difference as data on the blob, wouldn't that mean we miss out transactions in the intermediary transactions? Yes, you would miss all the data. You wouldn't know what transactions have been executed. But that's why if you need to know the details of transactions, you will have to go to a full node, a layer 2 full node. But to execute or to verify the validity proof, you don't need to know the transaction details. That's something that we discussed on session 1. One of the benefits of validity proof is that you don't have to know the details of the transactions to know if the execution is correct or not. That's why it's actually very efficient in that regard. Okay, great questions. So there are 2 ways, one that we have implemented and one that we want to implement in the future to reduce the cost of data availability. Data availability used to be 90% of the cost of a Starknet transaction. It was super expensive. But since EIP 4844 was activated on Ethereum, so now, as I mentioned, we send data availability data to layer 1 as blobs. And what creates, as I mentioned, is that there's a different type of layer 1 transaction and different market only for blobs that is not connected to the EVM, that is much cheaper. The downside is that you only have temporary storage of 1 month. Some people might decide to store it for longer, but the protocol requires really 1 month. It is much cheaper than cold data, the old method, which now it allows to have transactions on a Starknet that are less than 1 cent. which is really incredible because before with regular cold data, transactions were like a $1. Now we are planning to release another upgrade. I don't know by when, it's still TBD. But the idea that with Volition is that every time you send a transaction, you will have the option to store the data of your transaction either on chain or off chain. And you can decide that per transaction. Think about it like a selector, which two different prices for your transaction to be executed. If you choose to be off chain, it will be cheaper even than using blobs. So even though transactions are extremely cheap right now, like less than a cent, Volition will be important, especially for fully on-chain games, right? When you play a game that is fully on-chain, you probably will be sending, I don't know, in a game session, maybe 50 transactions. So even at 1 cent, they start to pile up if you play for longer. So if we manage to lower that maybe an order of magnitude even more, so it will make easier or cheaper, much cheaper to play actually on-chain games on Starknet. But it also opens the door for maybe the game publisher to subsidize some of the costs for the users. So at the end, users are completely unaware that the whole thing runs on the blockchain. They just feels like a regular game. The implementation date is still TBD. Question from Timitop. Can an L2 just decide to run Ethereum nodes of their own and store the blobs for their own L2 chain and just delete everything else? Can they? I guess you can have your own client that does that. Sure, why not? It's possible. But you will have to create your own client. I don't think there's a client that supports this out of the box. Bernardo's asking, smart contracts on Ethereum can include functions to store and retrieve blobs of data and are typically stored as by arrays within the contract storage. But due to cost and scalability, developers can utilize off-chain storage solutions such as IPFS or decentralized storage services. Will the recreation of L2 stable on L1 be different? All right, you say that you can retrieve those blobs from a smart contract. Well, it will come back as blobs, right? That you wouldn't really know what's in it unless you off-chain you decide to decode it somehow. Akash is asking, what are some drawbacks of Volition? Well, storing data off-chain, the guarantees of liveness are even lower, right? So you have the trade-off. Yeah. At least on Ethereum, you have a fully decentralized network, even though it's just for 1 month. It's like more like a data publishing than data storage, but at least it get published to 10,000s of computer. With off-chain publishing, it wouldn't be tens of thousands. It will be maybe 100 of nodes that will have access to that. So yeah, liveness guarantee will be lower. But the idea is that you don't need the same liveness guarantee for all the transactions. You can choose if you're doing something that is DeFi with more money, you want to have higher liveness guarantees. So with Volition, you can choose, okay, maybe I want to use blobs as normal. But you can also choose to have lower liveness guarantee for something that you really want it to be as cheap as possible, even if you sacrifice a bit of liveness. Just looking at the questions. Nico is asking, when you say off-chain, do you mean in the L2 layer? Could be L2 layer, could be something like Avail DA, could be something that is not Ethereum, basically. Patrick Sardar is asking, can you please explain what is cold data? I'm a bit new to this space. Cold data is basically when you call a method on Ethereum, you have to pass some arguments to the function. Those arguments are passed as cold data. That's like a temporary memory where you pass arguments. It's been used historically for rollups as well, and a way to encode data that is never really meant to be executed, but it was still expensive. PCWU is asking, what is the difference between Volition and layer 3 based on the Starknet? Those are different verticals. Volition is about data availability. Layer 3 is about where do you want to verify your validity proof? Do you want to verify on Ethereum, which makes you a layer 2, or do you want to verify it on a Starknet, which makes you a layer 3? I would assume that most layer 3s will use its own storage, so it will be off-chain storage, something like, again, could be Celestia, Eigenlayer, Avail, DA, something like that. This is what I mentioned about the Starknet being the cheapest and sub-cent transaction. You can see if you go to Growth the Pie, this website, you can compare with all the leading layer 2s, and Starknet is the cheapest. You can see it's significant decrease because you can see it over time, right? This is the moment that EIP 4844 got activated on Ethereum, and the Starknet was ready from layer 1 to actually make use of it. And you can see the dramatic reduction of the average transaction fees. So advantage is now dirt cheap to use the network. Disadvantage, not only for Starknet, for any other rollup, is that liveness guarantees are a little lower now. Blockchain, yeah. One thing that I not forgot, but I haven't mentioned yet, is that Sharp is more complex than just having a prover. And some of you actually point out that in order for Sharp to talk to Ethereum or send transactions, it needs to actually have an externally owned account, right? You need to sign Ethereum transaction in order to execute the verifier. So there is a module called the blockchain writer that includes an Ethereum EOA that is actually like the middleman sending transactions to Ethereum, either the validity proof, like the output from the prover. The blockchain writer is the one that mediates to send it to either the verifier or to post the data, the state diff, as a blob. Just to let you know that Sharp is more than just a prover, it has more modules there. Agustin is asking, Volition will open up a new DA storage on AW, Autonomous Worlds, I imagine, a cache or Filecoin, am I right? Yeah, it will open the door to use different, I don't know if you're going to be able to select which one you're going to use, or if Starknet is just going to choose one of those services to be the alternative to blob space. But again, we need to wait until the design is completed. There's a website that you can use where the engineers from Starknet actually share their thoughts about where the network is going and what changes is going to come in more detail in the Starknet forum. I don't know if they have things about data availability now, but you make sure to take a look at the articles here. Those are mostly written by Starknet engineers, so you can have an idea what they plan to implement in the future. This is an interesting read, Starknet applicative recursion. All right, back to the slides. We have just 3 more slides before the pop quiz. Look at the question in the QA. Okay, I'm gonna continue. Robert, if you can help me out answering some questions, I'll keep pushing forward. Let's talk about the Starknet OS. One question that I haven't answered is that why is the state difference the output of the prover? And the answer is actually the Starknet OS. The Starknet OS is a Cairo 0 program. It's like the old Cairo program. And the Starknet OS has as an input the current state of the network, also all the new blocks that have been created since the last time a validity proof was sent to layer 1. This new block, it will have declare account and invoke transactions that happen in multiple blocks. Also, as an input, it will have the class hashes of all the newly declared smart contract, the newly declared code, use the declared transactions, but also will have the compiled class hash, which I mentioned in session 1, was a way to overcome the sequencer from cheating during compilation. So it has all these 4 inputs, and the output is actually the state difference, right? Like if I execute all these transactions here and I compare it to the current state, what things have changed, right? So that is the state diff, it's one of the outputs. The other outputs is just the new things that have the new code that has been declared and its counterpart compiled class hash. Only because these things need to be also bundled into the data availability to be sent to Ethereum. So you have 3 things as output: the state diff and the new code has been declared on Starknet since last time. So that is what the Starknet OS does. The Starknet OS actually fits here after the Cairo VM. All the transactions, they go to the mempool, they get executed in the Cairo VM, and then they get bundled into blocks. And once multiple blocks are created, because now it's time to actually submit a validity proof for all of this execution. So the Starknet OS actually execute all these transactions that are being bundled into blocks. And it's the trace of the Starknet OS, the thing that has been sent to the prover. And the prover is actually called the Stone Prover. It's an open source system that you can use today. And basically it's able to prove Cairo 0 execution. It can also prove Cairo 1 code, but also Cairo 0. Starknet OS is still within Cairo 0 because you can click here, just take a look at it. Not to go into detail, but just for you to take a look. This is the old Cairo, but it's still being used. And the prover, the Stone Prover, takes that trace of that execution, and you can use a Stone Prover here. This is open source. You can play with it. Maybe I'm gonna put it in the chat. Stone Prover. So now you know. So what Sharp is really proving is the execution of the Starknet OS, basically deriving the new state diff out of all the transactions of all the new blocks being created, plus all the new code that's been declared. And the output is go to the blockchain writer, go to the verifier, goes to a blob for data availability. Okay. So just trying to add the missing piece here because I was trying to, before it looks like all the transactions go directly to the prover, but it's not the case. Really, there's the intermediary between the sequencer and Sharp is the Starknet OS, which is a Cairo program. Looking at the QA, okay, good. All right, so There are 3 types of rollup modes, and this is in general, not only for Starknet. You have the rollup mode, which is L2s that use Ethereum for data availability. That is what Starknet is doing today using blobs. You get better liveness, but it's more expensive, and Starknet is a rollup. Some systems are called validiums, which basically they don't use Ethereum for data availability. It's more liveness, but it's cheaper. An example of a validium could be a StarkX. Although a StarkX, you can also choose if you want to use it as a rollup. So it's basically any layer 2 that uses something like EigenLayer or Celestia. Those are called validiums because they're not using Ethereum as a data availability, they're using something else. And volition is basically a hybrid mode between rollup and validium that you get to choose per transaction whether you want to store your data on-chain, in this case in the rollup mode, or off-chain in the validium mode. And that's an option, a mode that is coming soon to Starknet. So in summary, data availability prevents the Starknet from getting stuck, which is the liveness problem, not knowing what the current state of the network is, so you're unable to progress to the next state. The Starknet sends state diffs, class hashes, and compiled class hashes as data availability. These are the outputs of the Starknet OS program. There's a thing called the memory pages, another one. I think this is actually, I need to update. This actually belongs to the old block space, not only for blobs. DA data is posted to Ethereum using blobs. This is correct. Let me just cross this out so I don't have it there next time. Sorry, I thought I updated all the slides, but some things actually fell through. So Starknet is the cheapest layer 2 subset transactions. You can see, grow the pie, you can see the stats yourself, and Volition will make even cheaper Starknet. So this is very important for gaming in particular. And in gaming, remember that we have session 6 is going to be about Dojo, which is a framework for fully on-chain games. So all games will be Dojo, which is going to benefit massively by Volition.